Homework 14, section 7.2, applications of the standard normal distribution, video 7. We're going to do one more example of converting a percent or a proportion or a percentile back into a measurement. This is still in the context of IQs. I erased a lot of the extra words. But let's say that the mean is 100, which it was, and the standard deviation was 15. Let's find the range of IQs containing the middle 90% of the population. Now, what do I mean by the middle 90% of the population? That means if we go to the center of our bell curve, which is 100, since that's the mean, then I want to cut off the middle 90%. In other words, 90% of the middle 90% of the population falls between these two scores. We'll call this one x1 and this one x2. Actually, I'm going to introduce a notation in the z picture in just a moment that we'll be using later on. But we're looking for the two scores that have the middle 90%. Now, when I say middle 90%, I mean that these two tails are the same size, and that's going to be important. So how are we going to find these x's? Well, the same way we did before. Find their z's and then turn them back into x's. So what would this picture look like if we did this for z's? And my apologies, in the last video, I did not label the axis as either x or z. Kind of important so you know which one it is. In a standard normal distribution, the center is always 0. And we're still looking to cut off the left and the right tail to capture the middle 90%. So if we can figure out these two z's, then we are going to be able to convert them to the x's. Now, I want to introduce you to a new notation on the z's. Just to be consistent with the textbook, I want to make sure that I'm writing this the same way they are later. And I'm pretty sure, yes. Oh, really? I'm glad I looked. Because what they have is something that's a little different than I was going to write. Okay, so I want to introduce you to z subscripted with a number. We're going to call that number alpha. The Greek letter alpha looks like what some people call the Jesus fish, but it's the first letter of the Greek alphabet and it's lowercase. But whenever you see a z subscripted with a number, this is the z with an area of alpha to the right. And that's why I wanted to look to make sure. We're so accustomed to saying left areas, left areas, left areas. But when we get to chapter 8, and we will, when a z is subscripted with a decimal number, that number is going to represent the area to the right. And let me just check one more thing real quick in terms of the author's choice of notation. Yes, this alpha is always going to be between 0 and 1, because as a percent, it would be between 0% and 100%. So as a decimal, it would be between 0 and 1. So if I wanted to write these z's subscripted, I would have to write down the areas to the right of them. So let's figure out what those areas are. How can we figure out the area of one of these tails? Well, we have to take advantage of two properties of any normal distribution curve. Number one, the total area is 100%. And number two, this is symmetrical, meaning that this area is the same as that area. So if the middle percent is 90%, how much would each tail have to be? Well, together the two tails would have to be 100% minus 90%, which is equal to 10%. But that's for both of them. And if they're the same size tail, then each one is half of 10%, which means that this area is 5%, and this area is 5%. Sorry, my red marker is a little chunky and I don't have another one, but I like it. I like my red marker. So if we wanted to correctly describe these z's relative to the areas to the right of them, this z on the right would be z sub 0.05, subscript 0.05, meaning the z with 5% to the right of it. But what would the subscript on this one be? It wouldn't be 5%, that's the percent to the left of it. What percent of the total area is to the right? 95%. To the right of this is the 90% plus the extra 5. So the correct notation using subscripts for this z would be z.95. Again, that seems a little backwards to me. I would always talk about the area to the left, but in this book, and I think it's actually industry standard, when you see a z subscripted with a decimal, that decimal represents the area to the right of it. But I digress. Let's find that area. Now, we know these are symmetric, which means when I know one, I know the other. They'll just be opposites. And I also know that in my z-table, my z-table contains left areas. So I can look up either one of these as long as I'm looking up the left area. Let's do z.95, which has 95% to the right, which means it has 5% to the left. So this left area is 0.05. But our areas in our z-table have 4 decimal places, so I'm going to append 2 zeros. And now I'm going to go look in my z-table, and if you have access to one, I would highly recommend doing it as well. And I'm going to look for the z that has 5% to the left of it. Now, I know the z is negative because it's to the left of 0, so I would need to go to the negative half of my table. And I'm going to look in the middle to find the number closest to 0.0500. You might want to pause the video and look for it for yourself, because I'm about to tell you where to find it. Okay. Go to the negative 1.6 row and go across. You will see 0.0505, but immediately after that, you will see 0.0495. Those are in columns 0.04 and 0.05 respectively. So I found the 2 areas in the middle of the z-table that 5% is in between. Remember, we're looking for 0.0500. But which one is closer? Well, they're exactly the same distance. Exactly the same distance. If I ignore the decimals and think of this as 500, this is 5 above 500, this is 5 below 500. Now, I know what my preference is. And I'm trying to find what the author's preference is in this particular case. And I think I found the evidence of it. So give me 1 minute to find that evidence. Answers on page 376. Sorry folks, I should have checked this out before. Really? That's what you're going to do? Oh, you're using your calculator. No calculator. Okay, so here's what I'm going to do, and it shouldn't give you any trouble in the homework, but if it does, click view an example and pass it on to me. But what I have always said in this situation, from the first time I ever taught stats, 14 years ago, if you're looking for an area in a z-table and it is dead center, I will always default to the larger digit on the top. So since we are dead center, I'll always default to the right and use that digit. So the z-score that I'm going to use for this is negative 1.65. There are some books that will say use the smaller digit and use negative 1.64. And there are some books that will say average the two and use negative 1.645. There's a reason why I prefer defaulting to the larger digit. Namely, if I default to the larger digit, it widens this range and makes this slightly larger than 90%. And in the context in which we're going to be seeing this later, making this percent larger is forgivable, making it smaller is not. So I will always default to the larger area, I will always default to the larger digit up top only if the area is dead center. If it's closer to one or the other, use that one. So what's the other z? Well, I could look up this left area, which is 95%, but remember that this is symmetric about 0, which means if the z that cuts off 5% in the left tail is negative 1.65, then the z that cuts off 5% in the right tail is positive 1.65. Make sure you understand where these z's came from before you move forward. Just to retrace the steps, we have 90% in the middle, which leaves 10% together with the two tails. So half of 10 is 5%, one tail is 5%. Left area here is 5%. Dead center between two areas in the z table, so I default to the larger digit up top. Negative 1.65. Symmetry says this one is 1.65. But we're not out of the woods yet, because that only gives us our z-scores. The question was, what interval of IQs contains the middle 90% of the population? So we have to take each of these z's and turn them back into measurements, back into x values. So our first x value, the one on the left, is going to be the mean, which is 100, plus its z-score of negative 1.65 times the standard deviation of 15. We'll calculate that in a second. And the second IQ, the one on the right that cuts off the 5% on the right tail, is going to be 100 plus its z-score, which was 1.65 times 15. So let's figure out what each of these is. 100 minus 1.65 times 15. 75.25 here, which means this one should be 124.75, but let me just double check it. Yes. All right, so what does this mean? This means that the middle 90% of the population has an IQ between 75.25 and 124.75. Or if we rounded it off, from 75 to 125. All right, I believe this wraps up this section. Please try some of the homework. It's not that difficult once you've decided on a plan of attack. I think I'll make one more video just summarizing the plans of attack.